Welcome to the Level 3 video on Arithmetic and Geometric series. Today we're going to be talking about infinite sums. And I mean infinite sums with respect to a geometric series. So, the big question is, what if our geometric series was infinite? So let's think about it mathematically. If k started at 1 and now n is infinity, we had a, the starting value, times r to the power of k minus 1. What is this? Well, it's actually relatively simple. This will only converge if the modulus of r is less than 1. Okay, so as long as r isn't actually 1 or minus 1, then if we continue to add up all the terms in this series, then it will actually converge onto a number. Okay, and the formula is the following. So again, this sum from k is 1 to infinity of a times r to the power of k minus 1 is equal to a all over 1 minus r. But remember, this is only if the modulus of r is less than 1, which is really important. And why is this true? Let's look at the proof. Okay, if we take limits of the original sum, let's go ahead and do that. So the limit as n tends to infinity of the sum of k is 1, n of a times r to the power of k minus 1 equals the sum of k equals 1 to infinity of a times r to the power of k minus 1. This will then equal the limit as n tends to infinity of a times in brackets 1 minus r to the n all over 1 minus r. Okay, and then we can pull the limit inside the bracket. So we have 1 minus the limit as n tends to infinity of r to the n over 1 minus r. And then this limit of r to the n will just tend to 0 because the modulus of r is less than 1. And if this tends to 0, then we have 1 over 1 minus r. And then discarding of the brackets, we have a over 1 minus r. And that's the end of the proof. Thanks very much for listening.